This is Trig Identities Part 3, and we're only going to go over one question for this video because this is a particularly difficult one. I mean, it looks simple enough, but it's through that simplicity that it is quite difficult. There's nothing I can do on either side. Think about it. There's no tans that I can change to sines over coses. There's no reciprocals. There's no sine squares or cos squares that I can change using the Pythagorean identity. So what exactly am I supposed to do? They don't look like each other, but you're telling me that they equal each other. Well, let me give you one extra tool that you can use in order to prove identities. Okay, so I'm going to work on the left-hand side just because it looks slightly more complicated, but we do want it to look like the right-hand side, so I'm also taking a look at the right-hand side and keeping that in mind. So the right-hand side does have a cos on the bottom, and I'm thinking, well, I'll probably want this to change eventually to a cos. It can only do that, though, if it was a sine squared x, not a sine x, because we know through the Pythagorean identity that sine squared x equals to 1 minus cos squared x, so I have that cos that I can change it into. Now, I could make the sine x into a sine squared x, by multiplying everything by sine x. So everything in the denominator by sine x. That would mean, though, that I would have changed this entire fraction because I'm multiplying it by something random that wasn't there before. How can you do that? That's not allowed. It is if you put the exact same thing on the top so that this fraction, when I divide the top by the bottom, it equals to 1. So even if I did multiply this entire fraction by 1, it hasn't actually changed anything. But now I get that sine squared on the bottom. I'm thinking, though, here's a problem. Sine x times sine x, great, I get my sine x squared. But then I'll have to multiply it by these two as well, and I'm just going to get more and more sines. And I don't want that. I want a cos. So that might not be the best way to go, but maybe we can use that type of logic to help us solve. So I'm going to show you the tool now. I will multiply it by something, but it's not going to be just the sine x. So I'll show you. I'm going to put brackets around this, and the reason I'm going to do that is because I'm going to assume that this is, maybe we'll call it a, and then we have minus, and then we have the b. Okay? So this is a binomial on the bottom. And then maybe if I multiply it by another binomial, I'll get a difference of squares. That's another way I can get my sine squared. Okay, so let's try that out. Your a is sine x plus cos x plus your b, which was 1. Okay, now remember, you have to have the same thing on the top so that this entire fraction equals to 1. Because if it doesn't really make sense. You've changed the original equation, well, expression. Okay, so what exactly does this do? Let's multiply the tops first. And I think we're going to have to do FOIL because we have a plus b, and then, I mean, this might have to be a different letter, maybe like c plus b, because b is the same, 1 and 1. Alright, so we're just going to do FOIL. Let's do a times c first. Equals sine x minus cos x times, and then c was sine x plus cos x. Alright, so that's done. Then we're going to do, for outside, that's a times b plus 1 times the brackets. So that's just going to be the brackets. Okay, and then we have b times c, because that's I for inside, plus 1 times the bracket is just going to be the bracket, sine x plus cos x, and then L for last, b times b. So 1 times 1 is just 1. Alright, now we're going to do the same to the bottom. But instead of doing FOIL again, I mean, why don't we just realize that we did set up a difference of squares. So since this is a minus b and a plus b, we're just going to get a squared minus b squared. Okay, so your a down here is sine x plus cos x squared, so that's your a squared, minus, and then your b was 1, and we're going to square that as well. Okay, now what we're going to do is we're going to expand everything. Notice that this part right here is a difference of squares because you have a minus b and a plus b. So then I'm just going to go, well, that equals to a squared minus b squared. Okay, then we have plus, so I'm right here, and why don't we take off those brackets? So we got sine x minus cos x, and then the other plus, so I'm doing the blue just so that you keep up with me, sine x plus cos x, and then plus 1, all over. Okay, and let's expand the bottom as well. So we're going to do FOIL for the brackets. Sine squared x plus 2 sine x cos x plus cos squared x. So I just did FOIL, but I didn't do it in a lot of steps. And then we're at the minus 1. Okay. Now what we're going to do is we're just going to put things together, and I probably need a little bit more space, so I'm just going to scroll down a bit. And as I scroll down, you want to make sure that you extend your line. Okay. So maybe these guys can go together. Sine squared x minus cos squared x plus 2 sine x's, and then those guys are going to cancel out, so that's gone, plus 1, all over. And then on the bottom, don't this added with this, I mean, doesn't that equal to 1 through the Pythagorean identity? But you're going to subtract 1, so that's gone, and all that's left is 2 sine x cos x. Alright, what I'm going to do now is I think I'm going to change on the top everything to sines, because take a look on the other side, everything at the top was all sines. So let's just change this cos squared x to sines, equals sine squared x minus 1 minus sine squared x, so that was the cos squared x before, 2 sine x plus 1, and then you have the 2 sine x cos x. Alright, equals, take off the brackets. Now remember that negative in front of the bracket is going to change the symbols. I think we're getting closer. Okay, and we're just going to keep moving, more space. Whoops. And maybe extend this guy a little bit. Alright. Okay, so we have 2 sine squares, 2 sines, and then it looks like the ones kind of cancel out. Alright. I have a good idea, and I'm thinking here is all these sines on the top. That's a good thing because it looks like the right-hand side, but there's that sign on the bottom that I need to get rid of. So here's what I'm thinking. If I factor out a 2 and a sine from the top, whatever's left from this guy will be just a sine. Okay, so 2 sine times sine gives you that 2 sine squared x. Plus, I mean, what's left from this guy if you take a 2 sine x out? That's just a 1. and then you have 2 sine x cos x on the bottom. Now you can cancel these guys out. So you can only cancel once you've factored it out of everything on the top. Equals sine x plus 1 over cos x, which is exactly what we had on the other side, just the top is in a different order. Okay, and at the very end, therefore, left side equals right side. So the tool that you can use is to multiply your original fraction by another fraction as long as the numerator matches the denominator.